So I'm just going to read off the factors. 3 was h plus 3, h plus 6. 4 was a plus 6, a plus 4. 5 was k plus 5, k plus 1. We did 6. 7 was, actually I think we did 7 too. You did 7 and 8. We did 7, we didn't do 8. Okay. 8 was x plus 4, x minus 2. 9, g plus 5, g minus 2. We did 10. 11, c plus 9, c minus 5. 12, n plus 7, n minus 4. 13, x plus 10, x minus 3. 14, a plus 6, a minus 1. Then we did 15 and 16. 17 was k minus 16, k plus 4. And 18 was x minus 18, x plus 4. Do we have questions on any of those? To sort of recap before we start our new notes for today. We talked about how to factor from GCF, how to factor using grouping when we have 4 terms, which is basically GCF twice, how to factor difference of squares when you have perfect squares, or if you have GCF and difference of squares, how to factor trinomials when a equals 1. The next thing we're going to do is factor trinomials where a is not 1. What's nice about that is some of the same rules we just talked about will apply here, but there'll also be some differences. Some of the things we've seen before will apply here, but there'll also be some differences. Okay. Make sure you are paying attention, as this may be new to most of you. So just like the last set of trinomials we were working with, there are rules that we need to follow. With these rules, it'll still be in this format, ax squared plus bx plus c, but the number in front of x squared will no longer be 1. It will be something else. Negative, positive, doesn't matter. Our first thing, we always need to look and check and see, is there GCF? If there's one, we could possibly factor out that GCF. It could change our entire trinomial back to the ones we were just doing, and then it'd be a little bit easier of our process. That's not always the case, though. If there's not a GCF, then we move on to these steps. So I'm going to talk through the steps, and then we'll actually do it. So if GCF does not apply, we're going to take whatever a is, the number in front of x squared, take whatever c is, the very last number. We're going to multiply those together. Figure out what that is. Then we're going to look for factors of that number that would multiply to be whatever that is, and still add to be the middle number. So that part's kind of the same. But once we find that, then we're going to make our trinomial a polynomial with 4 terms and use grouping so that we get our 2 factors. Talking through that sounds like a lot, it sounds confusing, but let's actually do it. So for example 1, do we have a GCF? Is there something I can divide out of all 3? No. So GCF is out, or you can say GCF is 1, so there's nothing I can really divide out. Nothing would change. So because of that, we're going to move on to the next step, which is taking number in front of x squared, and the last number, multiplying them together. And we now need factors of 6 that would multiply to be 6, but add to be 5. What are two numbers that would multiply to be 6, but add to be 5? Rated? 3 and 2. So once you have those, maybe write them off to the side, because we're not just going to go directly into our factors like we did before. Our next step, we're going to take whatever the first term is and the last term, keep those exactly the same. I'm going to rewrite this 2x squared, and at the end plus 3. Those two numbers we just found, that 3 and that 2, we're going to put them in the middle of this. Because we know if we had 3x and 2x and we added them together, we would get 5x. So we're taking this middle term, splitting it into our two factors, and adding x to it. So what I mean by that is this. It does not matter the order in which you write these two. You may want to put the 2's together because you know we could factor out 2's that way, or put the 3's together because you know you can factor 3's out. It doesn't matter. You'll get the same answer regardless as long as you do your math correctly. So now we have 4 terms. Grouping should come to mind because that's the only thing we can do with 4 terms besides GCF. So now I'm going to split this down the middle and look for what two things, or what could I divide out of the first 2 terms? 1, yes, 1x, there we go. So if I divide out x, what's left? (2x) plus 3. Remember with grouping that you need your insides to be the same. What could I divide out of these two? Just 1. And my inside would be the same. So then I could write my 2 factors, which are what and what. The x and this one. So x plus 1 is one of them. And 2x plus 3. So there's a lot that you have to do to get there. But once you get there, that's your answer. Now, with these, because it's not just a one-step thing, I would definitely check each one of these. So distribute it back out, make sure this works. X times 2x would give me 2x squared. X times 3 would give me 3x. 1 times 2x would give me 2x. 1 times 3 would give me 3. And if I, combine my like terms, I get 2x squared plus 5x. So that does work. Right now, what questions do we have on this process? If you want a way to maybe better organize some of your numbers, I know some teachers use this. I don't really because I don't. But if you wanted to make like a little X somewhere off to the side, in the top would be whatever number you get when you multiply. So our 6 would go there. And the bottom would be whatever number is in the middle. So our 5 would go there. And on the sides would be the 2 factors you get. So plus 3, plus 2. Just so you have somewhere to kind of organize those numbers. Do you have to do or use that? No. But if it helps you, use that. You also would need to know or remember what each piece means. So the first, or the top is multiplying A and C, the bottom is B, and this is factor 1 or factor 2. Let's do another one. Actually, before we do that, I did want to mention that our rules about plus, minus, minus, all of those still kind of apply. They're just a little different. So because we had 2 positives, our factors are going to also end up both positive. And then in this next one, we have a minus and a positive. So our 2 factors should be both negative. But we'll see that here in a second. Do we have a GCF here? No, other than 1. So that means nothing we divide out is going to change. So then we need to take A, or 5, and C, multiply them together to get positive 30. And then we need to find 2 numbers that multiply to be 30, but add or subtract to be 17. Negative 17. 30 has, not a lot, but it has a few factors, so listing them out wouldn't hurt. What are some factors of 30? 1 of 30, 2 of 15, and 10. Heard another one, but I didn't actually hear. 6 and 5. And that should be it. So of these, remember that negative, positive, they both need to be negative, or they both need to be, they both need to be negative. So which of these could we both make negative and add or subtract them together to get negative 17? 2 and 15 would work. So in your x, if you were doing that, this would be 30, negative 17, negative 2, negative 15. Then take our first and last. And we're going to input negative 2 and negative 15 along with our variable. This one, I want to purposely put 15 with the m, but that, again, does not matter. It would work out either way. And then I'm going to split this down the middle. What could I divide out of the first 2? 5. Is that the only thing they have in common? We divide out 5 and m. What's left? M minus 3. What can we divide out of the last 2? Yes, but this is negative. Remember, whatever this sign is going to be the sign of this, so negative 2. And if we divide out negative 2? The 3 would be negative, yes. What else?
Oh, M.
And then M. And our 2 factors would be 5m minus 2 and
N minus.
m minus 3. So that would be your final answer. I'm going to distribute this, make sure it works. 5m times m gives us 5m squared. 5m times negative 3 gives us negative 15m. Negative 2 times m gives us negative 2m. Negative 2 times negative 3 is positive 6. So 5m squared minus 17m plus 6 does work. Anyone have any questions on this so far? Let's try another. Number 3, do we have a GCF? 1. And then take 6 and negative 4, multiply them together. We get negative 24. And then we need to think about 2 numbers that would multiply to be negative 24. And add or subtract to be negative 5. 3 and negative 8, yep. So first and last term would stay the same. I'm going to put plus 3y minus 8y. And then go from there. And then we can start our grouping process. What could we divide out of the first 2? Divide 2 out of 3. You do 3. You were thinking divide by 3 and get 2. 2y plus 1. And what could we divide out of the second 2? Negative 4. 2 give us 2y plus 1. So our 2 factors are
Negative 3y minus 4.
3y minus 4
2y.
and 2y plus 1. Just to make sure that works, 3y times 2y is 6y squared. 3y times 1 is positive 3y. Negative 4 times positive 2y is negative 8y. Negative 4 times 1 is negative 4. 6y squared minus 5y minus 4. 2 negatives, 1 of your factors has to be negative. The bigger number would be the negative. That rule still applies. And then example 4. Do we have a GCF? GCF is 1, and then what would that be when we multiply it? Right? And then find two numbers that multiply to be negative 60, but add or subtract to be 11. Sixty has a lot of factors. 4 and 15. And which of those is the negative? The 4 would have to be negative because our 11 is positive. If we made the 15 negative, we'd have a negative 11. So positive, negative, one of them is negative, and it's the smaller of the two. First and last will stay the same. I'm going to switch this. I'm going to do positive 15C minus 4C. If you did it the other way, that's fine. Remember, we'll still get the same answer. It'll just look different for a second. What could we divide out of the first two? I was going to say, you guys said something at the same time that I didn't get it. 3, yes. And if we divide out 3C, what's left? You're really close. If we divide this by 3, what would be left? 4C plus 5. There we go. What would we divide out of the second two? -1. And that would leave us with good. And then what would our two factors be? -1, it's one of them. And 4C plus 1. 3C plus 3C times 4C is 12C squared. 3C times 5 is 15C. -1 times 4C is -4C. And then -5. So 12C squared plus 11C minus 5 is. Okay. We are going to stop there for today. Tomorrow you'll have more time to work through some examples, and then we'll talk some more through other things. If this did not make sense, any part of this did not make sense, maybe you weren't fully paying attention, you missed something and you just don't understand something, come see me after school today or Thursday, not tomorrow because I don't have office hours tomorrow. Also, if you haven't finished your tests, come do that after school today or Thursday. If you need to start test corrections and retest work for the benchmark, come see me after school today or tomorrow. You guys do have Delta Math and Khan Academy on what we did today, but you may want to wait until we finish these notes. Sorry, somebody to